Welcome. Let's look at arithmetic sequences and series. As you see, I have those yellow here. A sequence is a simple list, but a series is the sum of the list. Now, in a sequence, you have to have the same amount that you're adding or subtracting each time to get to the next term. In a sum, you take what you already made up as a sequence to add up to get the sum result. Let's go and take a look at the equation that for basically all sequences. And let's focus on what each of these things mean. This one is the amount of the term you want. We call it generally the nth term. Actually, nth is a word in the dictionary, so let's do nth, the nth term. A1, the 1 means the first term. So that's the amount of the first term. The amount of the first term. The n is the number of terms. And the number of terms here is the term that you want. So if you want the amount of the 23rd term, then the number of terms here, the n would be 23. And finally, the d is the common difference. Let's use this sequence, I should say, this sequence here to make the equation that matches it. So what we see is that the first term is indeed the one that comes first. And we also see that the difference is the amount that we need to go from -60 to -55, and then the same amount to get to the next number, -50. So it looks like that's 5 each time, and it's a positive 5. So what we do is we put that into the equation. So AN equals A1 -60. Actually, I'm going to start by writing the whole thing, and we'll put the things underneath it. A1 plus N minus 1 times D. So here AN equals -60 plus N minus 1 and 5. However, that's not acceptable because it's like leaving a fraction and not simplified. So like 2/4 would not be an acceptable answer, whereas that would have to be reduced to 1/2. Then it would be acceptable. This one's not acceptable because there are things you can do, specifically multiplying in here with the 5 and then combining like terms. So that means we would get -60 plus 5n minus 5, and the -60 and the -5 would go together, so I would get 5n minus 65. Okay. So that's what, in fact, I will put up here. AN equals 5n minus 65. I will box that here. So that's the equation following the format and simplified. So let me write out about that, about important note. An important note. Guess I was going to write note. You must simplify the equation if possible, as I showed here. Now, let's use that equation. In the next part, let's find the 150th term. We could add 5, 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 add 5. After a while, it gets tiring. That's the reason why we have these equations. It makes it much faster. We're going to say that the amount of the 150th term, because we're going to use that n, is equal to 5 times the 150 minus 65. So what I did is I filled in, this is an, and this is the n, following the equation there. And so the amount at the 150th place is equal to 750 minus 65, which is equal to 685. I did not want to count by fives going up to 685. This is much simpler. There's an alternate method to get a similar equation. Watch what happens when I box these. Now, what is happening here is that n equals 1, so that's the first term, and n equals 2, that's the second term. So here's n equals 3. So the top row are n's. I'm going to call them x's, and I'm going to call them y's here. And oh, we have an xy table. We can make y equals mx plus b with this. So think about this as points. These are actual points, 1 and negative 60, 2 and negative 55, 3 and negative 50. So what we can do is find the slope, and then from that, find the y-intercept. So for the slope, y equals the second y minus the first y over the second x minus the second x, put y accidentally. The second x minus the first x. So let's take the first two pairs because the numbers look easier. So the second pair, this is second, and this is first. So we have negative 55 minus a negative 60, and 2 minus 1. This becomes plus, so 60 plus negative 5, or negative 55 plus 60 is 5 over 1, which means we have a 5 for the slope. So we now have the equation y equals 5x plus b. We can find the b. Well, the b is when x is 0. Well, if we subtract, we're going 1, 2, 3, we can go back 1, then we would subtract 5. So I'm guessing it should be negative 65. Let's find out. Let's take one of these points, like the first one. Let's take the main one there. And let's put that into the equation. So the y is negative 60. We're using 1 and negative 60. Is equal to 5 times 1 plus 2. So that's a positive 5 here. So I'm going to subtract 5 from both sides. So let's rewrite it without the parentheses part in there. So 5 plus 3. Now let's subtract 5, and we get that negative 65 is equal to b. So our equation is that y is equal to 5x minus 65. Now, let's notice something about that. The 5 and the 65 come back up here, and we have 5 and negative 65. So y equals 5x minus 65 is actually the same as an equals 5n minus 65, because an arithmetic sequence is a straight line. So the formula that we use for it is essentially exactly the same as y equals mx plus b. So let's look now at finding the sum of a sequence. And this is where we can look at sigma notation. Sigma notation is specifically saying find the sum. So actually, I will take advantage of the fact I already wrote that. Find the sum. That's what this symbol means. I don't even have to write instructions. I can just put that you all know now that that simply means find the sum. So there's a formula that when you have this is a formula that's much easier to use to help you find a sum. And especially since we're going from 1 to 30 terms in the sequence. So we have to find the first 30 terms and add them up. That's tedious unless we use a formula. So here is the sum formula. There's two ways to write it, but they're the same essentially. I prefer n over 2 a1 plus an, the first term plus the last term. Some people, and the textbook prefers that it's this way. They essentially are the same thing. It doesn't really matter which way that you do it. I prefer the first one, but the second one is perfectly fine too. But no matter what, we need three things. We need the number of terms, the first term, and the last term. Number of terms, first term, and last term. So the first term, a1. To get a1, we take that 1 and put it in here. Equals negative 11 times 1 plus 26. Okay. So when we do that, we get negative 11 plus 26. We get 15. A1 equals 15. Now, the amount of the 30th term, which is the last term. Okay, so the amount of the 30th term is negative 11 times 30 plus 26, which is negative 330 plus 26, which means the 30th term is negative 304. Now we will use it with the sum formula. The sum out to 30 terms is equal to 30 over 2. The first term, 15, plus the second term, so plus minus means it's subtracting the 304. So the sum at 30 is 15 times 15 minus 304 is negative 289. Negative and such clear. And that's equal to negative 4,335. That would be the sum to 30 terms. I don't want to count that much. So finding the sum formula or using the sum formula is much faster and easier. So let me circle this with this bigger orange one, because that's a priority to know that sum formula. Now let's take a look at something where it's going to be to find the sum, but it's going to be set up a little differently. It's just worded differently. So you have to think about what's meant by this. Find the sum of the first 80 positive even integers. So we need a sum. There's 80 of them. It's the first 80. So it's starting at a certain place. Positive ones and even, like 2, 4, 6, 8. All right, so the 80 tells us that n equals 80. That's our n, our total, our number. Okay? And let's think about this in terms of a sequence. The amount of the first term is a 2. The amount of the second term is 4. The amount of the third term is 6, because the first even integer is 2. 0 is not considered even or odd. 1 is odd, so the first one is 2. They're positive, so we're not starting at like negative infinity type of thing, or any negative numbers. Now I could keep on going here. That's 3. Supposed to be a 3 there. Okay. But now I have some information. Remember now the sum formula, I have Sn equals n over 2 a1 plus an. I have right now the first term, which is the number 2, and I have the n, which is the number 80. But what I don't have is the amount of the last term. So I need a way to get to the last term. Right? So what I'm going to need to do is use the formula that we have. An equals a1 plus n minus 1d. So what I can do is, once I set up this formula, I can use it to get the amount of the 80th term. Well, I can't yet because right now I don't know the formula, or I don't know what the formula will be. However, I have some information for it. I have the first term 2 plus, oh, now here's 80 minus 1 times the d. I'm still going to need the d. Okay, so since I still need the d, wait a minute, the d comes from this. If I'm going to go from the first term to the second term, and then the second term to the third term, what do I do? Well, from 2 to 4 can either be multiplying by 2 or adding by 2. But when I'm at 4 going to 6, I'm not going to be multiplying by 2 or else I'd get 8. So it looks like plus 2 is the only thing I can do. So that means that the d is equal to 2. So I can erase the d and put in a 2. So what I've done is I figured out the d. I was given the n, and I sort of was given the first term because that's the first positive even integer. So there. But now I can do this calculation and I'll get what the 80th term is. In fact, I'll write A80 here. So the 80th term, the amount of that term is 2 plus 79 times 2. So the amount of the 80th term is 2 plus, that's 140, 158, plus 2 is equal to 160. Now I know what the amount of the last term is, and I can now put that in right over here. So let's do that over here. That the sum out to 80 terms is 80 over 2. Doesn't look like an 8, actually. There, that's a little better, I think. The first term is the amount of 2, and the last term at the 80th term is 160. So the sum of 80 is equal, of the 80th term is 40 times 162, and that means it's equal to, is it, oh, I need to write it as an 80, not an 18. Let's write it correctly here. That's 6,480. So that's the sum of the first 80 positive integers, 2, 4, 6, 8, all the way up to 160. Add them all up and you're at over 6,000, almost halfway to 7,000. Okay, now let's do an application that involves finding the sum of a sequence or a series, I should say. A stadium section has 20 seats in the first row. That looks like, say, this many. And 23 in the next row, and 26 in the next row, because there's 3 more each time, all the way up until one really big long one, that 38th row. So it's first row, second row, third row, and then 38th row, and a lot in between. Well, we know some things right now. Let's take these numbers and put them into a series or a sequence, because I won't add them up yet. 20, 23. 3 more seats is 26, 3 more seats is 29, and so on forever. But I know now the first number, and I know that the difference is equal to 3. Okay? And I know that n is 38, because we're only going to 38 rows. N equals 38. So just like the last problem, we have for the sum formula, Sn equals n over 2 a1 plus an. I have the first term. I have the n. Whoops. That's the n here. But I don't have the last term. The d will help us get the last term. I could just keep adding by 3s a million times, 30 up to the 38th time, actually. Not a million times, just 38 terms. However, what I can do is write out the formula. An equals a1 plus n minus 1 d. So I don't know what the amount is at the 38th term, but I'll find it by using the amount of the first term and the number of terms and the difference. So 38 minus 1 is 37, At 37 times 3 plus 20 comes to 131. So the amount of the 38th term is 131, and now we know what this is. So let's put that in over here, that the sum, that's 38 over 2. First term is 20, and then 131. So we have 19 times, whoops, I put an equal sign here when it wasn't supposed to be. So I think I'll rewrite the rest of that too. 20 plus 131. So it's 19 times 151. Oh, I keep forgetting to write the 38 here. So the sum out to the 38th term is 2,869. So that means there are 2,869 seats in row 38. That's a lot better than calculating 26, 29 for the fourth, 32 for the fifth, 35 for the sixth, and then keep going by threes until you've done it 38 times. Some people would be willing to do that, but the formula does make it much faster and easier to get to it. Now let's look at a different type of application. Company A pays $23,000 annually. Okay, I think I'll just do the 23,000 annually with raises of 1,200 a year. And then company B pays a higher amount at first, but with smaller raises, 26,800. So first, which company pays more in the 10th year? And in the 10th year, how much total money was made at both companies? So let's take a look at what we're going to do. I'm going to take first company and I'm going to find out some of this information. What is the 10th year amount and how much total money for that one? Then I'll do it for the second company and I will figure out what that one is and then I'll compare them. So for company A, first, what we want to do is how much in the 10th year. So I need the sum at 10 years. So that means I need the n, which is 10 over 2. The first amount, well, now let's actually look at this. For company A, the first amount, A1, is 23,000. The n is 10. And the common difference that's being added every year, is 1,200. So that's something I should have written first. But let's use that information now. Because here, the n over 2, and then the amount of the first one. But we don't know the ending amount. We need an. So an, this is A1. And this is n over here. That's supposed to be an n. It doesn't look much like an n. N equals 10. All right, good enough. So we have to find an, and we have to find it the same way we did before, that the amount of the 38th term is equal to, and I'll use an equals A1 plus n minus 1d. So the amount of the 38th term is the amount of the first term, 23,000, plus n, or 38, minus 1, times the common difference, which is 10. So that's just calculating that out. Okay, and when we do that, 37, oops. Oh, I put the 38 in the wrong place. Didn't I? Yep, so I put a few things in the wrong place. Let's fix this. The n is 10, so it's 10 minus 1. And then the common difference is this 1,200. Okay, so that would be 11 times 1,200, and then add to it 2,300, 23,000 here, down to 300. So the amount, wait a minute, whoops, this wasn't supposed to be there. Hold on. Okay. The amount of the first term, n minus 1, and d, and I keep putting this 38. Why am I putting 38? Oh, that's from the last term. I don't know why I wrote 38. So let me erase that for the last problem. I apologize. We're looking at the amount of the 10th term, and I knew something was up because this is supposed to match that. AN and the number of terms N. And it wasn't, and now I figured out why. I just wrote it accidentally from the problem above. Okay, now back to here. So the amount at the 10th term is the 11 times 1200 added to the 2300, and that gives us 33,800. That's what I need to go in here. 33,800. And I will work on that here. That's 10 over 2 is 5. 2,300 plus 33,800 is some large amount of money. 33, 50, 60, no, 56. 56,800. Okay. And it gives us a total of $284,000, 3 zeros. So that's a first amount for company A. That's how much it is in, well, actually, we have two things. That's the sum. And here is, whoa, don't go away. And this is the amount after 10 years. So it's the amount after 10 years here. That was one of the things we had to find. And the other one is the total money in 10 years. Now let's do it for company B. And we'll start off by identifying these things, that the first term, the amount that someone makes in the first year is 26,000. The N is 10. The common difference, this time, the raises are smaller every year, so it's 800. So in order to use the sum formula, S10 equals 10 over 2, 2,600, or 1,000 rather, plus we need to know the amount here of what it is after 10 years. So that means we need to get, so let's find the amount after 10 years. So we're going to do A1. Actually, let's write out that that's A1 equals AN plus N minus 1 times D. Oh, I wrote an N again. I keep wanting to write it, meaning to write it as a 1. So this is the N and this is the 1. First term goes inside there. Now, let's proceed with it. The amount of the first term is 26,000. The number of terms is 10, and the common difference is 800. So it's 9 times 800. There's a plus in here, plus the 26,000. So the amount of the 10th term is 33,200. So I now know that. So I can put that in here, 33,200, and then I can work on this equation, because now I can say that the sum at the 10th term is 5 times, add up those is 50, 61, 200, I believe. No, 69, 59, 200 there. 59, 200. Okay. And that comes that the sum after 10 years is, yes, better than that. The sum after 10 years is $296,000. That was 10 now. So let's compare. Whoa, I do not want that over there. Ah, there, that's better. Okay. So think about what this means. So in the 10th year, company A makes more because this is 3,800 and this is 33,000. Whoa, back again. $33,800 and $33,200. Company A person makes more money. Sum overall in 10 years, or all 10 years, company B makes more total. Instead of annual, it meant more total money. Or as an average through them, it would make more. Okay. So what we had to do here was to find the amounts after 10 years and then use the sum formulas to figure out the amounts here, the sums of them. So I'll put the sums in boxes. So the amount after 10 years and just the 10th year, and then the total of the 10 years. That's a more complicated one because you're doing everything twice. And it's got to keep track, as you noticed, I had to work harder at keeping track of each of the parts of it there. Now that you know that, hopefully I will help you with remembering it and how to do it right. Thank you for watching and listening.